The next method of integration that we discuss is trigonometric substitution. Now, the name trigonometric substitution, the term trigonometric substitution is used because this is a method of integration wherein an algebraic integrand is transformed into a trigonometric one. So this time, from an algebraic integrand, gikan sa algebraic, we convert it into a trigonometric integrand. So remember in our previous lesson, rationalizing substitution, or it's otherwise called as algebraic substitution because we just deal with algebraic functions. But this time, gikan sa algebraic, we convert it into trigonometric function, integrand. Now, similar to the other methods of integration, we must know when this method is applicable. Kanus aman mo gamit or kanus aman makagamit og trigonometric substitution. When can we use the method trigonometric substitution in evaluating an integral? So, this method is used when the integrand contains the following algebraic expressions. Number 1, if you see the pattern a squared minus u squared, or number 2, a squared plus u squared, which is just equal to u squared plus a squared. And number 3, if you see the pattern u squared minus a squared. Okay, it's important for us to know what these values are. So, we know that u is a differentiable function of x. Okay, differentiable function of x. And then a is an arbitrary constant. Or it's simply a constant. Let's just call it a constant. Alright. So if we see the pattern a squared minus u squared, remember it's substitution. So meaning we are going to introduce a new variable. Now this time, the variable that we introduce is the variable theta, because we're going to use a trigo function. So if you see the pattern a squared minus u squared, we let u equals a sine of theta. If we see the pattern a squared plus u squared or u squared plus a squared, then we let u equals a tangent of theta. But if we see u squared minus a squared, then we let u equals a secant of theta. So, kaning tulo. Diba, if you haven't forgotten yet, diba, these patterns are familiar to you. These are patterns that you saw in the integration formulas leading to inverse trigonometric functions. So those formulas were derived using trigo substitution. Now, because we are going to be converting into a trigonometric integrand, then there may be cases na kailangan mo apply sa solvable groups of trigonometric functions. And at the same time, we will be using the identities, the Pythagorean identities, sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. And cotangent, it's only up to tangent. Okay, no more cot. And then also we're going to be using right triangle trigonometry as we have discussed in the previous video. ba? If this is the triangle, if this is a right triangle here, then if this is x, this side is x and this side is y, then the hypotenuse would be the square root of x squared plus y squared. And so for the ratio of the sides, the 6 trigonometric functions are, if this angle here is theta, then sine theta equals x over square root of x squared plus y squared. If you have cosine theta, that is y over square root of x squared plus y squared. If you have tangent theta, then that is equal to x over y. Now, if the triangle was different, say, this is our triangle, right triangle. This is the right angle here. So, for example, the hypotenuse is x. We have the angle theta here. And then this side is y. So, our given here is x and y. So, what is the measure of this side? So, using the Pythagorean theorem, this is the square root of x squared minus y squared. And so, therefore, sine theta is equal to, what is the opposite side? Square root of x squared minus y squared over x. Cosine theta is equal to y over x. And tangent theta is equal to, what is tangent? Square root of x squared minus y squared over y. Then another case would be if the triangle is like this, and this is our right angle here. This is our angle theta. Now this, the hypotenuse is y. The opposite side is x. So using the Pythagorean theorem, our adjacent side would be equal to y squared minus x squared. And so sine theta is equal to x over y. Cosine theta is equal to the square root of y squared minus x squared. And tangent theta is equal to x over, by the way, cosine is square root of y squared minus x squared over y. Tangent theta is x over the square root of y squared minus x squared. So it really depends upon the given side, the angle, and the ratio. So for the other three ratios, cosecant, secant, and cotangent, we know that they are just the reciprocal of these three functions. So in the next videos, we'll be evaluating integrals using trigonometric substitutions.